All right, so thanks for joining this presentation. So this is the sixth edition of the Philly NLP Breakfast. So Philly NLP Breakfast is an online meetup with a short format, so between 30 and 45 minutes long, where the goal is to discuss everything NLP. So it's a reading group, so we can discuss NLP paper, research paper, but also if anyone has an exciting NLP project they are working on. So it's really a place to share knowledge in NLP, both practical and research knowledge in NLP. So this week I'm going to present Transfer NLP, which is a library that we are building and open sourcing to promote reproducible research and development. And the main goal is to facilitate transfer of code and knowledge. So this presentation will be overall an introduction to the framework. It will be a bit shorter than previous NLP Breakfast, and the goal is to have a discussion at the end to see how it can be useful and how it can be used for any kind of projects. So during this introduction, I will spend a bit of time at the beginning talking about reproducibility and why it's really important. And then I will go over the different steps that the frameworks allows. So basically the frameworks allow to define and configure experiments and make it easy to keep track of different experiments that you are using. And the main goal is to have reproducible experiments so that when you are happy with developing your tool, you can just share minimal things with your colleague or open sourcing, and it can work wherever, so your code is not broken and you can feel confident about your experiments. Then I will talk a little bit about potential NLP building blocks that we can include in the framework. And I will give an example of how to use a framework to do transfer learning. So based on a pre-trained model, how to use it for a custom task. And I will conclude by getting some direction on how to use it for your projects in general, whether it's a research project or an application project. So the fundamental brick of Transfer NLP is promoting reproducibility. So reproducibility is very important for many reasons. So you already know reproducibility importance in terms of software engineering. So your code needs to be runnable from anywhere. It needs to be tested. It needs to be versioned. So this is very important facts of reproducibility in software engineering. Oh, can you see the slides? Hi, Victor.
Present now. I think.
Oh,
No.
I'm actually sharing.
Yeah. So it's on. It's on the other side. You have a list of smaller.
So if you are in Google Hangout, you can see on the side you have different. Okay. But anyway, the slides will be opened, and the slides will be added to the blog post, so that you can have a look after that. Yeah. So so reproducibility is very important for code sharing first. So if you are the only one who are experimenting with the project and you are the only one running the experiment, it's likely that your code is broken unless someone else will test it and try to reproduce the same result of your experiment. So this is really important in a team with different colleagues, but it's even more important when you have an open source project. So you want to make sure that your experiments give the same results wherever you run them. Technical credibility is also very important, because when you publish a paper or when you assess that you have the new state-of-the-art model on some task, you want to make sure that anyone can verify this, can fact-check it, and having a reproducible experiment for that allows for technical credibility of your work. Then reproducibility in machine learning is really important for incremental research and improvements, and having a way to have strong baselines. Because if you have a reproducible experiment, you can build on top of it. But if your experiment is weak, the code is always breaking, it will be very difficult to build on top of it and to be flexible on this. So having reproducible research is a real good asset for that and for incremental research. And finally, reproducibility is very important when you want to work on a lateral thinking project. So if you want to work on different modeling ideas, on different tasks or on different data sets, you don't want to restart from scratch every time. So if you have a different sets of isolated building blocks that you are able to reproduce, this is a really strong asset to have in your different projects. So yeah, first, the core of the library is how to best define experiments and how to keep track of them. So I will briefly introduce this with an example. So the basic of Transfer NLP is defining experiments and loading them. And what is an experiment? So to be flexible and general enough, we can assume that when you are experimenting with some stuff, you will define your classes, you will have different objects, and your experiment is about using these objects to interact and build some things. So a really common experiment is about training a model. So to use the library, so you define your different objects as you do as always. And the Transfer NLP library enables to take an experiment JSON file, as here, where in this file you would define all your objects that the experiment will use. And the experiment loader will build the objects from this JSON file. And then you can just do whatever you want with these objects. So if you want to train a trainer, what you will do is just take the object trainer and do whatever you want. So use a train method if it's what you want. So here, if you look at this experiment file, we try to make the configuration file as general as possible for the beginning. So really, the basic of it is you have objects and you instantiate them. So here you have a data loader object, which has a name, my data loader. So this is the name of the class it will look into. So it will try to instantiate an object of this class, and then you can specify parameters. And parameters can also be objects, so that it can be a recursive instantiation. And if your parameters are optional, for example, you are not bound to put them in this. So if you don't put them here, the config loader will just use optional parameters or default parameters. And so every of these objects are quite independent. So you have a data loader here, a model, which is my model object, an optimizer, here it's an Adam optimizer, and a trainer. So in this example, the trainer is the most important object of the experiment, and it takes several objects as parameters. And so the most important objects of the trainer is the model, and you want to use the model that you have instantiated before. So using this dollar character enables you to say that, hey, I want the object model which is supposed to be somewhere in the experiment already instantiated. So you can just notify by using this dollar. And if actually the object's model is already present in the experiment, you could also not specify it in the experiment file. So here I've put it to show that it's possible to do it, but you are not bound to that. So overall here, this is a deep learning independent way of instantiate objects. It's just instantiate an experiment and then do whatever you like. And here you can see that there is a path parameter which leads to some logs directory where I want to log some TensorBoard loggings. So this is also a very important fact of reproducibility. So when you look at, for example, typically notebooks where researchers will share their experiments, you will see a lot in notebooks personal paths, which is really a mess for reproducibility. So here we use we use like environment variables where anyone can use their own home, define their environment variable, so that this code can run in any computer, and a user would just have to define its own environment variables. So this is the core of the library. But one question that you could ask is that, suppose I have an experiment, but I want to experiment with different set of parameters. So if I get back to here, my model has a parameter hyperparam, which is 10. There is a learning rate for the optimizer. So maybe I want to experiment with different set of parameters. But if I do that, I will have to have multiple experiment files, which are actually almost the same, but change in just a few parameters. So it would be great if we could reduce this problem. And also, what if I want to remove some parts of the experiments and see how it affects the results? So a typical example of this is, suppose you have a model training a classifier of text, and you use different kind of embeddings at the beginning. So suppose you use word embeddings with Glove, character embeddings, and Elmo, and you concatenate them. You have results after a training, and then you want to ask, okay, what was the impact of Elmo? What if I remove Elmo? What will be the result? What if I remove Elmo and character? What will be the result? So in order to avoid the problem of having multiple experiment files for the actual same experiments, we suggest having one experiment file for the experiment. And if you want to experiment with different parameters, you would define a config file, which here is really like CFG file where you just parse this. And so here I take the same experiment than before. But if you look at the learning rate here, I've put a $LR here, and the hyperparam of the model, I put a $, here, which say that it will look at the config file. And here in this config file, you have two configuration possibilities. One with a hyperparam set to 100, and one with a learning rate of 0.1, and another configuration setting with different parameters. So you could have many different configurations as you want. And the framework allows you to run these different configurations for the same experiment sequentially. And you can implement a reporter. So this should be left to the freedom of the user. So suppose you're doing this sequential search and you want to get track of what's happening in the end. You can implement a reporter. So in this example, the reporter will just store the different metrics for each of these configurations. And at the end, this will produce a directory with a summary of everything. So there will be the summary of the experiment file, which is a JSON, and the summary of all the results from the different parameter settings. So this solves the problem of having multiple experiment JSON file. Okay, so now that we have a core library to load experiments and to keep track of them, we could ask, can we have general enough building blocks so that we don't have to rebuild all the NLP blocks every time we work on a new project? So one building block that is available on the library right now is a PyTorch trainer. So at the beginning, we were building the PyTorch trainer by ourselves with all the different utilities that the trainer can bring. But after some time, we discovered the Ignite project. So Ignite is a PyTorch project which goal is to help facilitate the building of trainers. So we use it in our PyTorch trainer. And this is really good to have events handling. So when you're doing a training job, so most of the time you will go over different epoch. So one epoch is one pass over your whole data. And for each batch, you will do some things, some optimization steps. And Ignite allows you to do some actions at each of these events. So you can do any custom actions after every batch or before every batch, after every epoch, or at the end of the training. You can really customize this. And it's actually really easy to work with Ignite. And it's really convenient to add TensorBall loggings whenever events you want to record it. And yeah, basically it's a good practice to use TensorBall to monitor your training during the training, so that during the training you can see most of, like, as much as possible of the model is doing. So you can monitor the metrics, you can monitor how big are the parameters, you can monitor the gradients, you can, if you are interested in embeddings, you can actually visualize your embeddings, and you can also use nearest neighbors just to debug if your embeddings are right. So yeah, Ignite is a very good tool, and we came up with a basic trainer which should fit for most of the supervised learning tasks. Yeah. Another building block that we are providing is a predictor. So in the case where you are training a model, at the end you want to use this model for doing prediction at inference. So yeah, so there is an abstract predictor class that you can implement, and so this is model specific. So the developer of the model knows exactly what they want to have. So it's led to the user to implement how it can use a batch of data and outputs a result. But in the end, a question we had while developing this library is, do we actually need NLP building blocks? And if we do, how much of them do we really need? Because the problem of building blocks is that it can bring some flexibility constraints. So once you have a lot of building blocks that are really useful for some experiments that you are running, but suppose you want to experiment with something else and you can't use these building blocks, it's really hard to let the creativity in place, and it brings a lot of constraints. So yeah, so the goal of the library is for now to become to keep as much minimalist and flexible as possible, because building blocks are useful when we can actually reuse them for different purposes, and whether we can extend them and change them. And another reason why NLP building blocks is not necessary is that there is already an active NLP community which is producing a lot of good content, which is available open source, so which makes the need for yet another NLP library not that useful. So yeah, there are a lot of very useful libraries like NLP, PyTorch, Pre-trained Brain, you have Flare, PyText. So any of these libraries already have building blocks that you can actually reuse in TransferNLP, and TransferNLP allows you to have control of your experiments, and you can then use other people's code to extend it quite easily. So TransferNLP wants to promote transfer of code, but also transfer of knowledge, which is the core of transfer learning. But transfer learning is using large pre-trained models that are made available online to adapt them to custom tasks. So here I've put an example of using a model from the PyTorch pre-trained BERT repository. So if you don't know this repository, it's a really good repository to get started with all the transformer models that are available, and most of them are implemented in PyTorch, and it's really easy to play with them. And here I've put an example of how to use a model from PyTorch pre-trained Brain, how to use it in a control experiment. So here, all the code necessary to run these experiments is condensed into this code. And so basically you have a vectorizer that builds a list of symbols for your input text. And this uses the BERT tokenizer, which comes from the library, and a data loader, which enables you to have a PyTorch loader for your training, evaluation, and testing data. And here, because we reuse the code from the library, all we have to do is to use the register plugin decorator to make sure that the library can actually use them. And then here is the control experiment. So this defines all the objects that are used in the experiment, and you can play with different versions of BERT. So here it's the basic version, which is BERT based in case, but you could also use other version. So this version is used in the vectorizer. Here you can see that the object vectorizer uses this parameter. So this is useful for the tokenizer, because the tokenizer is dependent on this version. And the version is also important for the model. So if you want to experiment with a model which has another version of BERT, you can really easily change it. So for this, you can also see this fine-tune parameter here. So it's a parameter that we propose in the trainer, the PyTorch trainer class that we propose. And this fine-tune parameter allows the trainer to train only on the last projection layer of the transformer model. So it's really fine-tuning a pre-trained model to a custom task. Yeah. So at the end of this slide, there are some links, and there is a Google Colab notebook where you can actually run this on a certain dataset. So the notebook shows how to load the dataset and how to execute this code, and you can have interactively the TensorBoard loggings of this experiment. So you can monitor it. And yeah, so to finish with, I'll talk a little bit on how we can use the framework in a concrete way. So for now, the way to experiment with the library is bring your own classes. So as much as possible, I think research, it's really important that people keep having their own objects, their own methodologies, and not adding some constraints on people. So people can have their own classes, and you register them to the library with the register plugin decorator. And so you can use your own classes and with a mix of someone else's code. And so we saw in the previous slide that to use someone else's classes, you just have to import it and to register it. And then you can use it just as if it was yours. Then the rest is optional, but is good practice. So you can implement your reporter so that you can have control of your different experiments and your different configuration settings. You can implement your own predictor so that you're not just doing research, but at the end of the day, you have an object for inference that you can use to serve your model. So in a Flask server, for example. And yeah, so for now, the trainer that we propose should fit most of the single task supervised settings. But if you want to experiment with different settings, for example, multitask learning, Ignite, so the Ignite project, makes it actually really easy to change the current trainer and to adapt it to the multitask settings. So concretely, you would just have to change a few basic methods to fit the needs of multitasking. And also, so I was mentioning that we have a PyTorch trainer for now, but because the core of the library is only about loading experiments and running them, it's not dependent on PyTorch. So we like PyTorch and we will work with PyTorch for now. But if you prefer working with TensorFlow or Keras or Dynet or another framework, feel free to implement another trainer for this. And overall, so we will try to keep minimalism on the building blocks in the common project. But if you feel that some building blocks are general enough to be added to the project, feel free to open a PR and a discussion to make sure that this is flexible enough and it doesn't add constraints. Yep. So thank you very much. And so if you have questions and if you want to discuss it, so this would be a very good time to know how it can be useful in different projects. And these slides will be made available on the blog post announcing the meetup. And here are some useful links that you can have a look at. So there is a Transfer NLP repository. but also a book on Python that was an inspiration for this library, a talk on reproducibility, which is also a very important inspiration of this library, and the PyTorch retrain BERT repository and PyTorch Ignit's repository that are very important for this library. Thank you. So if you have questions.
So provided you put in the good seed arguments for all of the steps of your JSON, you are sure 100% that when you rerun the thing, you will have exactly the same results.
Yeah. Well, if you don't have uncertainty in your method. Well, no, actually, yeah. If you put a seed, you are.
Because I remember that if you want to have everything exactly the same, there are many places where you need to set that random parameter, because the optimizer is random, the initialization is random, so many things are random.
Yeah. So for now, there is one seed for the whole experiment.
Okay.
Predictor? Okay. So for now, it's not yet Dockerizing, but I agree it's a really good practice, and it will have to include this. Yeah, definitely. Yeah. Yeah, so that's definitely the direction that we could take. We're not yet there, definitely. But yeah, that's a really good idea. Mhm. Yeah. So basically, the approach that we're taking is that we're building the library step by step. So using concrete examples. And so right now we are going to start seeing how we can use the library for our own projects. And once we do that, we will encounter these kind of issues. And along this way, like, the library will be improved over. Mhm. Okay. And so, do you have any ideas on how? So, what would be lacking for now in the library for reach this? So, Dockerfile, I think it's a is a clear is a. Yeah. yeah, so it will be exciting to improve the product as much as possible and the library, and yeah.
Great insight. Thanks, Victor.
Yeah, thank you.
Peter had one question for you.
Mm-hmm.
If you don't like, maybe that's a basic question, but you mentioned that you have these different flavors and you can run these different reports. Is the idea of this tool to also have some kind of reporting so that it's easier to determine, what the results are, or is the output like? Does that need to be somehow standardized, or?
I'm not sure it should be standardized. For now, I would let the reporting parts flexible to the user, because people don't want to report the same things. But yeah. So for now, there is an abstract class for reporting, and then everyone can report what they want. Yeah.
And you mentioned a little bit like notebook at some point. Is the vision for this that it's more of a command line tool that you run, and so the way I look at it is, okay, Quentin was doing some tests while he was here working on common topics, and then Louis is interested to be able to rerun what was the baseline of common topics on leadership. Is that the use case we're trying to solve here? And
yeah. So basically having a strong baseline that you can work on it even 6 months after. So definitely using notebooks should be banned from reproducible.
But how do you merge those things? Because it seems that you guys always start by your research starts in these notebooks, and you do a lot of before you find you have all these trails that you go down to try to determine what the right thing is. So is the vision that people start with a notebook, and then whenever they're ready or something, then they will have to build an experiment?
So my advice would be use a notebook only at the end, when you have a controlled experiment and controlled environment, well, all the Python requirements and everything. And once you have all this control, you can put it in the notebook. Because using notebooks, there are a lot of reproducibility problems, because we could do a whole presentation about this, but notebooks is really great to present something, and to when I don't know a project, it's really easy to onboard a new project with a notebook which explains what's inside. But usually, it's hard to start developing with notebooks, and I don't think it should be recommended.
Yeah. The two things that makes this interesting is it seems that it's going more to more standard software thing. It seems that there is a research part of things when people are more researching and documenting and trying, and then there is the production aspect that Victor was talking about, which is the reproducibility of once you've deployed something in production, to almost have like more of a monitoring dashboard system where you're like, how are things changing over time compared to what I was before, and both of these aspects seem interesting. If this framework can somehow connect create a bridge between those two environments, it seems that it would be pretty awesome.
Yeah.
Who's excited? Who's looking forward to using it?
Yeah, sure.
You have good customers. That's the most important thing. Quentin, once you're back, I think that's going to be one of the things to play with. See,
Thanks for the logo as well.
It's awesome that you find this beachhead of reproducibility as a really focused area where you can go really deep. I think the notion of reproducibility and experiment feel really, really interesting.
Yeah. So we actually started the project with another vision. So the starting of this project was, hey, let's build an NLP library. But we started with building blocks and we progressively improved it. And by augmenting the library, the reproducibility part was actually the main challenge. And we thought that, maybe instead of building yet another NLP library, let's focus on the reproducibility part.
And that's smart. And I think working with people like Victor or others who are beyond, just building it, but starting to put these things in production and thinking about really kind of the whole product life cycle. Even us internally, you see, like we've done a bunch of experiments in the past, but as we bring new people in, we see that this concept of reproducibility is really key. You're now kind of pushing the edges to somewhere that is, the next kind of, it feels like the next step. So that's pretty exciting. That's cool. Especially if you're going to open it and bring lots of ideas from other people and other practitioners and focus on their real problems. I think that's usually a good sign of building something that's useful. All right.
Thank you, everyone.
We got the breakfast. It was a little bit late. So.
Here is what you are missing, Andy. Chocolate croissant from chez Colette.
Yeah, we have to have some incentive for the people who come in here. We haven't virtualized this yet.
Okay. Thank you very much.
Thank you.
Thank you.
Thanks.
Have a great day.